The mighty Rio Grande, Rio Bravo, is a centerpiece of folklore and music in the American Southwest. The Rio Grande, Rio Bravo is ancient, an ancient source of life to humans in the southwestern US. The human history along the Rio Grande, Rio Bravo, and its tributaries runs deep. The Rio Grande, Rio Bravo is multinational. Numerous Native American independent nations exist along the river and its tributaries, and the river spans multiple countries over time. The Rio Grande, Rio Bravo is culturally distinct. Distinct regional cultures are important considerations in water management along this river. And the Rio Grande, Rio Bravo is highly altered. It's been altered by the construction of dams, the filling of reservoirs, channelization, over-appropriation of water, diversions, and invasions of non-native riparian vegetation. The Rio Grande, Rio Bravo has complex hydrology and management. The river is managed under a myriad of jurisdictions with numerous claims on the water, and it is fought over. The Rio Grande, Rio Bravo is water short overall, and its flows are highly variable. The Rio Grande, Rio Bravo is threatened by aridification that is associated with climate change. This is a quote from recent literature. The Rio Grande offers the best example of how climate change-induced flow decline might sink a major system into permanent drought. The New York Times says, the Rio Grande is dying. Does anybody care? Hi, I'm Dagmar Llewellyn. I work at the Bureau of Reclamation, but I am giving you this talk today as a member of the Rio Grande Research Collaborative. So I'm speaking independently, not on behalf of the Bureau, so that we can all speak freely here. The presentation that I'm about to give is one that was the keynote for a talk at a workshop, on large river basin management for the National Academies of Science in Washington, DC last November. And I think that, Professor Morgan just wanted to say a word or two about this talk and the research collaborative then before we move forward with the rest of the talk. And you're muted.
I just wanted to welcome Dagmar and thank you for coming here to speak on your own time and share. She's definitely a hydrologist in the basin, has worked here for many years. She's got a lot to share today, so please put your questions in the chat. If you don't get a chance to answer them today, we will get to them hopefully at a later time. This is a chance for us to kind of get on a level playing field with regard to our understanding of some of the complexities of the basin. So with that, I'm just going to turn it back over to Dagmar, and also note that our next speaker in 2 weeks will be talking about some of the governance efforts in the basin. So please make a note to come back in 2 weeks for Colin Hafley with Nature Conservancy to talk about the Rio Grande Water Fund. But for now, we're going to talk about sort of the current socio-ecological system dynamics in the basin. So thank you, Dagmar.
Thank you, Professor Morgan. The Rio Grande is shown here along with the Mississippi River. These were the two rivers that were being compared and contrasted in this workshop on large river basin management for the National Academies of Science last November. And I think we can see that there's a significant difference here. Big one is the color of the background. The Rio Grande is the third longest river in the US, but it drains these very red or arid regions, and that really affects the character of the water management challenges that we have here in contrast to the Mississippi. Management challenges for the Rio are emblematic of those of many Western US river basins. Water scarcity plays a key role in water management. Water supplies are highly variable, but they're declining as the climate warms. Groundwater mining has decreased the ability of the river to convey water and is depleting the drought buffer. Tribal water rights have not been fully defined, but are considered senior to non-Indian rights. And requirements to support listed endangered species add a sort of new constraint on water management within the system. So we hear all kinds of talk about the woe is us, the Colorado, and the challenges that they have and will have if there were to be shortages experienced downstream of Lake Mead. And I contend, and I contended to the National Academies, that the Rio Grande has been experiencing these changes already. The lowest storage reservoir that we have in the system is Elephant Butte. There are others downstream in Texas in a different part of the river, but they don't sort of control the overall supply of water in the way that Elephant Butte does. And we have, since 2003, consistently experienced drought conditions, water shortages downstream of Elephant Butte in the Rio Grande project, Reclamation's Rio Grande project. And I think that it's instructive for those on the Colorado to see how that is played out. Certainly there's been a lot of innovations, ways that we've found to get around the shortages, but we've also wound up in the Supreme Court fighting over that water supply. And so I think it's, I think it's highly constructive, both instructive for both us and for those practicing in the Colorado River to see how this has played out. So this is our system, including both the Rio Grande and the Pecos, which meets the Rio Grande downstream in Texas. Couple of things of note here. One is that the majority of the water infrastructure that we have on the Rio Grande is in New Mexico, where most of us are practicing. A couple of dams down in Texas along the Mexican border and a couple up in Colorado. And then downstream of the upper Rio Grande, the portions in Colorado and New Mexico where we're all practicing, actually the majority of the watershed's in Mexico. And I think that that's really important to keep in mind as we move forward discussing the management of the system. This is truly an international river. It's been multinational throughout its history, actually, multinational amongst the various Anasazi tribes who lived here historically. Then it became part of Spain, then part of Mexico. In 1848, with the Treaty of Guadalupe Hidalgo, it became part of territorial United States, and then finally became part of several states within the United States of America, forming the southern border across the bottom of Texas. So really, there's three distinct rivers that are all part of the Rio Grande, Rio Bravo complex. The one that we're familiar with and talk so much about is the same one, actually, I show here that John Wesley Powell also highlighted. He cut the watershed off right about Hudspeth County, Texas, interestingly, where we cut off the upper Rio Grande. And we really have something entirely different downstream of there. So the headwaters we're very familiar with, start up in Colorado, come down through central New Mexico, down to El Paso, Texas. And at that point, most of the watershed from there on down is in Mexico, and the river forms the southern border. Downstream of that, we have the Forgotten Reach, and this is a place where the channel is dry except during floods. So then when there's water downstream of that, where the Rio Conchas comes in from Mexico, we have really what could be considered, under most circumstances, an entirely different river. This is the Forgotten Reach. So downstream of Hudspeth County, where we cut off the upper Rio Grande as we define it. And really what we see is fields of salt cedar and other non-natives that fill what should be a river channel. This goes on for, I think, 150 miles or so. And when we talk about the Rio Grande, I think we skip over this part. But if we were to have continuous flows in the river, this would be part of our river. So as I mentioned earlier, within this multi-sectioned river system, we have highly complex water management and allocation with overlapping jurisdictions, which don't necessarily line up with those three distinct different reaches of the river. We have 2 nations that manage it, with conventions and treaties dividing the waters between US and Mexico, places where we have to provide them water, places where they have to provide us water. There's 3 US states, the Rio Grande and Pecos compacts equitably apportion the waters between Colorado, Mexico, and Texas, or in the case of the Pecos, just New Mexico and Texas. And then there are 4 Mexican states that also share this water and have their own operational rules and management complexities. In addition to that, we import water that is New Mexico's allocation under the Colorado River Compact. So there's 3 compacts now that are affecting the water here. This is the San Juan Chama Drinking Water Project. For those in Albuquerque, you're actually not this year, but in most years, likely drinking water from that project when you turn on your tap. Key part of the drinking water supply for central New Mexico. And then, of course, there are numerous tribal nations, which, as I previously mentioned, have the senior water rights in the basin in most places, but they haven't actually been quantified in many areas. So, of course, that makes it hard to figure out what's left over for everyone else, and is a very significant water management challenge. Within the states in the United States that distribute the waters of the Rio Grande and the Rio Pecos, there's different water management rules, and so it's hard to convey sort of ideas across the whole basin, because each are subject to different kinds of operational rules. In Colorado, they practice priority administration on a 10-day cycle multiple times throughout the season. Today you get water and you don't, and tomorrow you'll get it and they don't. In New Mexico, the priority administration is in the state constitution. However, the water rights haven't been adjudicated along much of the basin, and therefore it's not actually done. I contend that the reason that New Mexicans often call this the nuclear option of making a priority call is that it's contrary to the history and culture of the state. And I think that's something this research collaborative might discuss a bit further. But the governance in historical New Mexico through the acequia culture was built around shortage sharing agreements, sharing within the community. And so since that's a key part of our culture, the, well, Reclamation imposed, I will note, priority administration system just might not be a good fit. I think the paper that you read talks a bit about that and some options for dealing with that challenge. Colorado and New Mexico consider surface water and groundwater to be interconnected, but Texas has a rule of capture for groundwater. Basically, if you can get it, it's yours. And you can see how that would lead to differences in the kinds of solutions that you can come up with for water shortages. So I'm going to go through a few of the different things that are going on within this river basin that add some of this complexity. One is certainly the federal water projects. Reclamation, primarily in the Western United States, manages water projects for water supply, primarily for irrigation, but sometimes for other purposes. Each one has designated purposes. And then the Army Corps of Engineers provides flood control reservoirs. Along the border, these reservoirs are controlled by the International Boundary Water Commission, which can play both roles, but it needs to be particularly on the border. So even within the federal system, there's multiple agencies and multiple jurisdictions. So here's the Rio Grande in Albuquerque today. And I ask you, is this a natural system? It certainly feels like one when I go for a walk along the Bosque in Albuquerque, but really it's a highly altered system. We've made many changes as we've tried to harvest the resources of this river and live along it in ways that are safe from flooding. That's led to all kinds of geomorphic changes within the system that I think are highly visible, as we'll see in the upcoming slides. It changes the hydrology, the sediment loads, reduces flood peaks, alters the timing of floods. It changes the relationship between the river and the floodplain. It narrows and simplifies the channel. There's all kinds of changes that have occurred because of these changes in hydrology and the installation of dams by federal reservoirs, such as those by the agency that I work for. Downstream of dams, situations change just from that existence of the dams and the changes that are in hydrology that are associated with them. So for example, the loss of the disturbance regime, the natural very wide swings in hydrology that we have within this system, has made the river corridor more hospitable to invasive species or non-native species that become invasive in this environment than to our native species. And so we've certainly seen a lot of spread of Russian olive and tamarisk. This picture of tamarisk is from when they were healthy. Now we have an additional complexity where a beetle, a native predator of the tamarisk, has been released and is altering the landscape yet again. Once we've changed our bosque system by making it hospitable to all of these non-natives, and now we're making it so it's harder for those non-natives to be there. So there's a major landscape transformation going underway right now, and it'll be interesting to see how that plays out, and there's a lot of research potential there for members of this community. Another way that the system's changed is through the development of agriculture and the increasing complexity of that agricultural development over time, from the historical water use of the native people who lived along the corridor to the kinds of things that we see today. There's an image of the San Luis Valley and all of the center pivot irrigation that's prevalent up in that corridor. We still use flood irrigation type practices in central New Mexico. This image shows the complexity of the network that distributes the water throughout the system in order to provide water for that flood irrigation. Another way that we've changed is through municipal growth, and that municipal growth often relies on the transfer of water rights from agriculture. So once we have the agriculture in place, then we've gone ahead and altered that. Municipal use has also relied heavily on groundwater, which then alters the interaction between surface water and groundwater along the river corridor. Excuse me a second. So here's how we wind up. These images from Raining in the Rio Grande created by Fred Phillips show the kinds of changes that the system has undergone because of the ways that we've been pulling water out of the system, storing it in reservoirs, diverting it for agricultural and municipal and other uses. So we can see there was this big wide blue line, which is the flows we had before 1600. And then the flows today, which are much narrower and then show the flows ending at the top of the Forgotten Reach. We've also purposefully altered the channels themselves. This is in central New Mexico. We wanted to build a city right along the river so that we could be near the beautiful Rio Grande, but it was kind of an unruly system. And so we put in these multiple jacks like children play with, really lined up and tied together along the river corridor. And what they did was that they trapped sediment moving down the river and built up the floodplain so that we could have a distinct channel in a specific location. So you can see the changes that have occurred from that and other channelization efforts over time. Up in the upper left corner of this slide, we see an image of the Rio Grande in 1935, and follow through the years. You see more and more simplification of the system until down in 2001, we have something similar to what we see today. Maybe a little less water today, but a narrow single thread, which defines our our corridor. And then most of the places where the water had previously been, the multiple channel threads, we see green, we see bosque growing. An ecosystem that certainly in central New Mexico we treasure, but I think it's worth noting that it isn't what was there historically. This is the channel from above in the Bosque del Apache Reach in 1935, showing all of those multiple channels. And this is in Isleta today. You can really see the strong difference between how the Rio Grande used to behave and how unruly it used to be, and the ways that we've tamed it today. And I think it's very much worth noting that that most of what used to be the river is today taken up with our treasured bosque. And that bosque sits up on top of a high floodplain with the river quite a good distance below. This is the Rio Grande at Central Avenue in 1933. And in the circle out there, it's a little bit faint, but you can make out the control tower, which apparently was there already at the Albuquerque Sunport. But what you see is a river with many channels, very little vegetation, and it's about a half-mile wide. This is from Central Avenue. This is what it looks like today. You see our treasured bosque, but a very confined river that runs in a very defined channel. So again, we've actually, despite the fact that the river is dry in certain portions in central New Mexico today, we've actually got more water running through the system than we had historically, because we're importing water from the Colorado River Basin through Reclamation's San Juan Chama project. That water is brought through a network of tunnels underneath the Continental Divide, fully by gravity. There's no pumping, and gets stored in Heron Reservoir, where the 16 contractors, now I believe 17, get their water over the course of a year through complex arrangements with the Bureau of Reclamation for that water's distribution. And then finally, we also alter the system through our pumping of groundwater. And as I noted previously, that changes the surface water and groundwater interaction, as well as our ability to convey water through the river without losing it out the bottom. So here's the system that we have today. It's about what it looks like today, I would say. But within that system, there's a lot of valuable services that are provided by the river. First, we've talked about agriculture, and the Bureau of Reclamation's projects certainly support that agricultural community. It's different in different portions of the basin. Barley, potatoes, grass-fed beef up in the San Luis Valley of Colorado, in central New Mexico, alfalfa and pasture primarily, with high cultural value and low economic value. But certainly that cultural value is extremely important to the culture of the community. And then different kinds of crops as we move our way downstream, chilies and onions in the Mesilla Valley, and pecans, of course, which are a key part of our economy in southern New Mexico. And then other crops in the Texas portion as we move into a different kind of climate regime. We're talking about cotton and citrus and vegetables. So there's a huge diversity of agriculture that's supported by the river. The river also provides water for domestic, municipal, and industrial uses in a myriad of cities throughout the basin, both in all three basin states, and then both in the US and in Mexico. Flood risk management is also provided by the infrastructure along the river corridor through primarily federal reservoirs of the Corps of Engineers and the International Boundary and Water Commission. Reclamation also, storage reservoirs can be used for flood control. When we get to that point, generally Reclamation turns them over to the Corps of Engineers. And then irrigation districts provide drainage services within the lands around the river. Hydropower. this infrastructure that we have along the river and the water that flows in the river also provides hydropower generation and a number of plants throughout the system. And recreation. The reservoirs provide boating, the rivers provide rafting, they provide fishing, there's walking and bird watching within the river corridor. There are many ways that we love our river and the waters that that flow through it wherever we put them, and we like to get outside and find opportunities to express that love by being close to the water. The river also provides key environmental services, from the waters provided in the alpine headwater ecosystems down through the river and riparian habitats that it provides along the river, through national forests, through national parks and wildlife refuges that are spread throughout the corridor. And there certainly are many species and ecosystems that are supported by this river and need to be a key consideration as we plan for any kind of changes in the river. That's something that we've realized recently in our water management, and certainly in central New Mexico, that portion of the river where we distributed all of the water and came up with all of this infrastructure, and then realized that we forgot the ecosystem and we need to provide some water for the endangered species. And that's been a major effort of water management and water management changes in the in the Rio Grande in central New Mexico for the last couple of decades, primarily focused on the Rio Grande silvery minnow and the southwestern willow flycatcher. I think in a lot of ways what we found is that these species that have been thriving within the Rio Grande corridor for millennia depend on the disturbance regimes that were historically characteristic of the river and that we've taken away to minimize flood risk to ourselves. And so there's a balancing question there that's been a key part of water management and habitat restoration decision making. What did I say here? Along with the growth of invasive non-native vegetation, the decline of these species correlates with the loss of floodplain connection for the river. So we do things to make up for that, such as drying the river and then taking these seine nets, collecting endangered fish and moving them to places where the river is not dry. We do a lot of very heavy management of these conservation reliant species. Finally, I think we should spend some time talking about the ways that this highly altered system is changing today. The temperatures in all of the basin states, and certainly in Mexico too, although not shown on this slide, are rapidly changing today. These three graphs show the changes in temperature on average in the three basin states over the past 50 years since about 1970. And although the temperatures are different in the three states, the slope of this line is pretty similar, and it shows pretty dramatic increases in temperature. These temperature increases have very significant impacts on, or implications for, all aspects of our water supply, because our water supply interacts so strongly with temperature in terms of the form that it takes initially and its relationship with the air above us. So the first thing to point out is that as it gets warmer, less of our precipitation falls as snow, more falls as rain. And the snow that does form has a harder time actually building up a snowpack in the winter. So this slide is sort of old, but the most recent projections don't really show anything different. This is from our 2011 Secure Report to Congress, and or I'm saying our Reclamations. And it shows a whole lot of red here. This is the comparison between the snowpack on April 1st in the 2070s compared to the 1990s. And what we're seeing in the New Mexico portion, so below the dashed line here, is that there's an awful lot of red, which is somewhere between, say, 75 and 100% loss in our snowpack by the 2070s. So as an important part of our supply as snowpack is, I think this should be a very, very sobering image for most of us. So these kinds of changes also lead to changes in the timing of flows in the river downstream. So from that same analysis here in the 2011 report, we show that this is, for example, on the Rio Chama in northern New Mexico, the wintertime flows, December through March, actually increase. Well, those flows are representing what we would previously have been storing in snowpack in the mountains. It's running down, and so we need to figure out how to use or detain that water in order for it to still be available to us in the dry summers. This is the Clausius-Clapeyron relationship, showing the exponential relationship between the temperature and the amount of moisture that air can hold. This shows the reason why your hair dryer works or why your clothes dryer works. Small increases in temperature up in the range where we live lead to large changes in the amount of moisture that air can hold. So, and we all understand this from the perspective of, say, relative humidity. The amount of 100% humidity in the wintertime is very different from 100% humidity in the summertime. So this curve has huge implications for how much of a sort of suction there is, how much of a draw there is to take our liquid water and put it up into the atmosphere and blow it away into the winds off to more humid places, unfortunately. There's all kinds of implications for that. There's implications to our soils and the moisture in our soils. There's implications for our open water. This shows what happens then if we have these winds and we have dried out soils because of these higher temperatures and changes in precipitation patterns. They'll put dust on our snow. So the snowpack that we have left is again threatened because it's got this dark stuff on top of it, which absorbs the energy from the sunlight and then melts away. We found that sunlight is more of a driver of melting of snow than is actual temperature itself directly. So notably here, there's that little cone of white snow that's sticking up into space, somehow avoided the dust, and that's not melted or sublimated like the snow around it. So that proves that point here. So groundwater, that's where we can keep our water away from all these increasing temperatures, right? We keep it underground, it's nice and cool down there, it can't directly evaporate. So what's the problem with that? Well, I mean, certainly there are some primary impacts on groundwater in terms of how much we are able to recharge our groundwater systems, but the primary problem with it is that as we decrease our surface water supply, we rely more heavily on our groundwater resources. And this image I showed previously shows then what happens to our surface water supplies as we pump groundwater to make up for the losses of surface water. You can see this going around in a circle. Less surface water to seep down into the ground means we pump more from the ground, and then both the surface water and the groundwater decline. This is something that has been getting a lot of attention in the news this week, or the last several weeks, as we've been all been looking at smoke-filled skies. I'm currently in Boston, dealing with an issue with my family, and we've had smoke from California all the way out here. And I think that I've said for a long time, folks in the eastern United States haven't really been aware of the degree to which the western United States is losing its forests. We're losing our forests through beetle kill. This is 2002 in the Santa Fe area, when many of you might remember us losing our piñons so rapidly that year, and through wildfire. This is the aftermath of the Los Conchas fires in the Jemez Mountains. We're losing that, and we're losing the ability to store our snowpack out of sunlight within those trees. So a reminder of some work that many of you might have seen from researcher Park Williams, now at Lamont Doherty Laboratory. But if you combine that, that exponential curve that shows how much moisture the air can hold with the increasing temperatures and these changes in our forest, he predicted that if climate models are correct, the average drought stress on our trees in upland forests by the 2050s will match that of the worst years during the largest mega droughts in at least the last 1,000 years. So the stress on our forests is intense. And I think with the terrible fires that have happened this summer in the Western United States and particularly in California, I think the people of the United States are getting a wake-up call to this. We haven't burned badly in the Rio Grande Basin this year, but that doesn't mean that we won't next year. I think it's a major threat to all of the Western forests and therefore the water supplies that come from those Western forests. And of course, the impacts of these fires and subsequent debris flows make their way downstream and affect all of our systems. This shows some aftermath of the Los Conchas fire in the Jemez Mountains. First, the fire, the burning of trees, subsequent debris flows that wash away the downstream watersheds. From there, ash has worked its way into the Rio Grande. Both Santa Fe and Albuquerque were unable to divert water from their treatment plants for a while after that. There were fish kills. So these problems don't just stay within the upland forests. They work their way through the entire system and are a key consideration as we try to manage our water because it affects our water quality. So the summer monsoons, one area with, well, I will say potentially a little bit of hope, but at least some concepts that might be good thought experiments for a research collaborative. What if the summer monsoons change? What if potentially they strengthen? Does that in order to manage that water, we have to do it really differently from how we've done it in the past, where we've set up all of this infrastructure up in the headwaters to collect the snow melt. But is this something that could help us to continue to thrive, at least for a period of time, in central New Mexico? But there are downsides to that as we lose our forests, because just small amounts of water on these very fresh wildfire scars can lead to significant debris flows. This shows September 2013, when this happened in the Peralta Canyon, it's kind of near Cochiti Reservoir. And this debris flow came down and actually blocked the Rio Grande and required that actually a number of federal servants came out during a government shutdown to take this back out. So in summary of these kinds of changes, in the summary of the challenges that we have within the basin, I'll say water scarcity and aridification are our primary concern, increasing hydrologic variability, and a decreasing ability of us to predict what our water supply in a given year is going to look like, because we're exiting the window of predictability. There's risks to upland forests from predators and catastrophic wildfires associated with the loss of ability to store water as snow, and an associated risk of debris flows. There's perching of the riverbed and loss of connection between the river and the floodplain. There's endangered species and a loss of ecological resilience. Finally, we have the challenge of aging infrastructure, especially in federal projects, but also the infrastructure throughout the basin that are used by irrigation districts and municipalities. But there's an opportunity embedded in this one, in that if this infrastructure is inappropriate for our future, then maybe it's an opportunity to try to build something that works better for the future that we foresee. And finally, I'll touch on some of the legal and policy challenges associated with water management within this system, or at least some of the examples that could be considered in some of the research in this collaborative. I've touched on this a little bit in that there's so many overlapping jurisdictions and variations in water management throughout the basin, but there's some things that are consistent, and that is, and some of those include the rigidity of the operating rules for federal rivers and reservoirs. It seems that there may be ways that we could improve our water management by changing those operational authorities, but I think that in order to do that, someone would have to make a really good case for making those changes, because acts of Congress would be required to make the changes. The rigidity of the priority administration water rights system, I've talked a little bit about that, and ways that we might discuss how it is potentially not consistent with the history of New Mexico, the place where it's in the Constitution but not currently practiced. And so there may be ways to propose a different system that might work better. And I think New Mexico has been doing a lot of shortage sharing agreements and then not implementing priority administration, but maybe there's ways, such as were talked about in the paper that you read before this lecture, of more systematically changing this rigidity. Okay, I just said this one. Sorry. There's a need for clarification of Native American water rights. As I said earlier, these are our most senior water rights, and we provide water to those tribes for their historical uses first. But it's hard to know how much there is left for everyone else, especially as the water supplies change. And so I would say that there's a need for clarification of what those rights are. And there is a lack of consistent accounting of the impacts of groundwater pumping on surface water supplies, especially due to the different ways of accounting for groundwater use and interaction between groundwater and surface water in the different states. And finally, there's conflict over the Rio Grande Compact currently in the Supreme Court. Some unknowns within the system are the outcomes of that Supreme Court litigation, Texas v. New Mexico, and how that will affect the agriculture and the economy in all of the states and the Republic of Mexico. Everybody would be affected by the outcome of this lawsuit. The impact of the tamarack beetle, which I mentioned earlier. There's a major landscape transformation underway in the riparian corridor, and we don't know where that's leading. And then, of course, the tribal water rights settlements. As I talked about, we're working our way through those, trying to quantify the rights of our most senior water users, but we haven't completed that process yet. So that's still a major unknown. So what are we doing to address these concerns? Besides hoping for a scientist to fly in and save the day. There's a number of things that are going on within the basin, science activities, and then also engineering and construction activities to try to address some of these challenges. And I'll run through a few of those, and I'm sure that many of you know others, and I think that these will become a key part of the discussion in this collaborative over time. So some things that I know I've been involved with include improvements to monitoring and accessibility of data. They're hail to the New Mexico Water Data Act. And that's both the physical parameters and of management activities. We're doing improved monitoring of crop and riparian evapotranspiration, reservoir evaporation, also groundwater use and levels, and a number of other parameters. We're working on improvements to forecasting of both spring snowmelt runoff and summer precipitation, primarily the monsoon. Reclamation's been doing some work on that with the National Center for Atmospheric Research, and then also collaborating with the state of New Mexico, who's doing some work to try to better forecast their annual obligations under the Rio Grande Compact. We've been working on developing projections of future water supply and demand, incorporating the impacts of climate change and the use of models to develop potential adaptations to those changes. We're doing research into brackish water desalination in order to increase our supply, research into snow processes and changes in interaction between the snow accumulation and melt and the forests and their own changes. And then research into ecosystems and endangered species needs. So to the extent that we can keep those species continuing with viable populations within the Rio Grande corridor. So I talked a little bit about the research that we're doing or have been doing at Reclamation and the National Center for Atmospheric Research on the summer monsoons. And I find this potentially exciting, really intriguing. What this shows is some different kind of summertime weather types that set up in New Mexico. And I want to draw your attention to the far right where it says WT or weather type 4. This is using a series of community earth system models into the future, looking at how the conditions that set up across the whole United States that are consistent with summer monsoons in New Mexico, how they play out over time. And we found something really interesting here, showing consistently across a number of models that the monsoon conditions are declining in the state until about the mid-2040s, and then they're increasing through the rest of the century. Now that could provide an opportunity for a new sort of water supply for us to use to meet our needs, but we haven't yet figured out why this is happening. We just see that it's consistently happening in the models that we've run. Could be changes in ocean circulation because of melting of polar sea ice, something like that. We're really not sure what the change is at this point, but it does provide some intriguing, I won't quite call it evidence, but some suggestion that we might be dealing with different monsoon conditions in the future, and that gives us something to talk about in terms of the ways that we might change our water management in order to take advantage of that and enjoy the summer monsoons in Albuquerque like has been done in the past. This is an image of a collaboration that Reclamation has with the University of New Mexico, Jake Collison through the Civil Engineering Department. And this is his Collison Floating Evaporation Pan, or CFEP. Historically, we've measured reservoir evaporations through basically a little dish of water sitting in a parking lot, which really doesn't represent the conditions that are experienced on a reservoir within the sort of the vapor bubble that forms over the reservoir. And so what he's done here is have a pan that evaporates on the surface, plus all of the instrumentation needed to do calculations of evaporation using the Penman-Monteith equation, so that he can compare those and see if this floating pan provides us a better indicator of the amount of loss that we have from the reservoirs. Other things we're doing have to do with conservation and planning. So there are federal programs to support irrigation district conveyance efficiency, improvements to on-farm efficiency. There's municipal conservation programs, drought contingency planning processes so that entities can still get the water they need to their highest priority uses during times of shortage. And then also transportation and land use planning and urban flood management. All of that work was done by the Mid-Region Council of Governments in Central New Mexico. So there's a number of planning efforts that are taking this information and trying to come up with new ways of thinking about our water management as conditions change into the future. One program that is used widely to do that is Reclamation's Water Smart program. There's a number of different programs there that provide funding to the local community, both for planning activities and then also for actions that are recommended in those planning activities. One that I'm sure you've all heard of is the Basin Study Program, because we're initiating a significant 3-year effort for basin study in the New Mexico portion of, or a portion of New Mexico's reach of the Rio Grande, where we're trying to get all of the major stakeholders in the basin together to envision a different future, different ways of managing into the future, different kinds of science that needs to be done, and different kinds of actions that can be taken to help us thrive during a period of a growing gap between water supply and demand. There are also physical system improvements going on. Habitat restoration efforts by many entities in the valley to reconnect the river and the floodplain, and also down in a perched reach down in the headwaters of Elephant Butte, to realign the river channel in order to be in a lower part of the valley with less of that perching. So more of the natural processes can take place. There are actions underway to improve some of the aging infrastructure that we talked about, such as the Safety of Dams project at El Vado Dam. There's upland forest thinning and controlled burns in order to increase the resilience of our upland forest, and we'll hear more about that from Colin Haffey from the Nature Conservancy next week. And there are river maintenance activities in order to, while we do all this, also maintain the safety of the river itself and the infrastructure along it, our roads and bridges and things that interact with the river. Some images of this hydraulic reconnection that I was talking about for the habitat restoration here. And here are some images of the realigning of the river channel. You can see in the lower image, you can see the water sort of flowing overland out from the old channel that was perched into a new channel on the eastern side of the river. And here's what it looks like after the realignment. You can see the old dry channel in the left side of the image. This is the El Vado Safety of Dams project, trying to repair the surface of the dam to remove some leaks, and then also rebuild the spillway so that we actually have some capacity for rapid releases in times of flooding. So the next section here is on science recommendations, both for data and modeling. And in the discussion that we had right before this talk, Professor Morgan and Irene Gray and I talked about potentially putting this portion of the talk off into the future as part of the science collaborative. These are topics that we might want to, each one of these things might be something that we want to seed future discussions with, and see if we can put our research heads together onto these topics. So I think what I'll do is I will end the presentation here, knowing we'll talk about those things later, and answer in the last few minutes any questions that you might have.
Thank you so much, Dagmar. I've seen this presentation before, but there's always something I learn, and there's so much complexity and rich texture to this basin and the questions that arise within it. We just have a few minutes, so I'm just wondering if anyone has a burning question for Dagmar that they would like to share, they want to put in the chat or speak up, because I can't see everyone at this point. Do you want to go ahead and, yeah, go ahead, Kathleen?
Yeah, hi. Thanks so much, Dagmar. It's always a pleasure to hear about all this. Again, I feel the same way Mindy does. I've heard a lot of this before, but you put it together really nicely. I had a question, and I put it in the chat, but when you were talking about that 2011 study looking at the sort of future drying out of the northern Rio Grande Basin, is there a tandem study, a paired study that looks at the piece of the San Juan Basin that we take through the tunnel and deliver to Albuquerque? Because I think that would be a really helpful piece of information for me. And it would kind of fill out the Albuquerque story a little bit better. But all I really know about the San Juan Basin is that it was, it's considered very reliable.
Yep.
And I'm not sure.
And that's actually that is what we've found in the projection work that we've done in the basin thus far, that the flows off of the San Juan Mountains are likely more reliable than those coming from the Sangre de Cristos, for example. Now, the headwaters of the Rio Grande come from both. There's some water from the Sangres and some water from the San Juans, but the western side of the San Juans seems to be even more reliable than the eastern side. And I think it has something to do with the fact that the winter frontal systems that bring our snow come in from the west, and this is the first big mountain range that they hit in this region, so they tend to lose a lot of their moisture there. Anyway, the projections that we're currently in the process of developing new projection sets as part of the Rio Grande Basin study, but the ones that we've done in the past suggested a significantly lower rate of loss of water supply in the San Juan headwaters, and therefore the San Juan Chama project, than in the main stem of the Rio Grande. And that has huge sort of socioeconomic implications. So it's really, I hope that's a topic that the research collaborative is able to discuss further in the future.
Thank you, and I'll look forward to that new report. Thank you.
Absolutely. There's so much going on in this basin. Dagmar listed a lot of good questions for us. And I don't know about you guys, but I ended up writing down a few extra questions myself in the process of her talk. So please use the Slack site. I forgot to mention that I did shortchange Dagmar's biography, but I did push it to the Slack site in part because I want to encourage people to use it. People have been uploading their introductions. So please, if you haven't already done so, get onto that site, upload yours, and check out those of others. We'll be putting this recording up on Slack so you can revisit it. And I think we're going to start compiling maybe some of these questions that are coming up for people, and maybe some of the ideas that are coming out of the from the talk. That kind of good to start maybe an ongoing discussion question that might get us rolling, because we're not going to have time to talk about it further. I would love to keep everybody on for 2 more hours of discussion, but that just isn't practical because we're out of time, and I'm dedicated to keeping people on time. So thank you, Dagmar, so much for taking time out of your time in Boston to join us. And this was a fantastic talk. Thanks to everybody who joined us, and I'll see everybody in 2 weeks. Enjoy. Appreciate it.
Thanks again, Dagmar.
Thank you, Dagmar.
You're welcome. Good to see you, Laurel.
Good to see you.